So we left off looking at quadratic equations and graphing them last time. We had them in a particular form so that we could graph it. We could tell where particular points were, where like the vertex was. And then we found intercepts to help us graph. So let's see. Let's just kind of review real quick. And then we're going to jump into 11.6, which helps us get these equations in the form so that we can tell what the vertex is, the vertex form. So recall, if you have a quadratic equation, y is equal to x squared plus bx plus c. This can be written in vertex form, which is y is equal to, you have the same coefficient a that you had in that original one, all times the quantity x minus h. That quantity is squared plus k. Okay. So if it's in this vertex form, we could tell a couple things. We could tell that the vertex was at the point HK. And we talked about that you had to be careful when you were looking at this. It was the opposite side inside the parentheses, because notice this is x minus h here. And so it was opposite sign here. Where it was the same sign when it was outside the parentheses for your y value. We also talked about last week that this coefficient a, which is also written right here, the value of a tells us the direction of the parabola. So the sign of a tells us the direction the parabola faces. Okay, so if a was greater than 0, the parabola faced upwards. And if a was less than 0, then we knew that the parabola faced downwards. And looking at this, depending on which way it faced, we had a particular value at our vertex. We either had a minimum value. So if a was bigger than 0, we knew that we were going to get an absolute minimum value. And if a was negative, we knew that we got a max at our vertex. We also talked about these equations being symmetrical across the vertical line that went through the vertex. So for instance, if we had a graph and where a parabola was facing upwards, doesn't matter which direction it was facing though. This value here is the h value of our vertex. The x value is h. The y value we call is k. And notice if you fold your paper vertically along that line, you're going to have a symmetrical image across each other. So this is y, or not y. A vertical line is always in the form of x. So this is the equation x equals h. And this is called the axis of symmetry. So we also talked about when we were looking for the intercepts, it was always going to cross the y-axis when you have a parabola that faces up or down. Later courses, you will see parabolas can face other directions like left and right. But for now, when our parabola is facing up or down, it's always going to cross the y-axis. Notice the image that I just did does not cross the x-axis. And that's going to happen if your vertex is either above or below the x-axis. So you need to determine where your vertex is and then determine what direction your parabola faces. And you can see by knowing what direction it faces, where the vertex is it going to pass or cross the x-axis. So that could save you some work when you're trying to find those values. If you did not see that and you were looking for those x-intercepts where it's crossing the x-axis, that's when your y value is 0. And we just did all those tools. We learned how to solve quadratic equations. And you would look at when is those x values set that equation equal to 0. What's going to happen if it doesn't cross the x-axis is you're going to get a complex number as a solution. So you're going to get a negative number underneath that square root. So if that happens, that just tells us that it does not cross. Okay, so let's just go over a quick example of it in this form, and then we're going to jump into 11.6, which talks about how to put it in that form if it's not in it. So let's look at an example. And let's just start a new page so I have plenty of room. Okay, so let's say that you have y is equal to, or f of x is equal to, which is the same thing as y, 1/2 all times the quantity x plus 1 quantity squared minus 3/2. Okay, so looking at this, what is the vertex? Okay, so again, we want to look at what is your h value and your k value. So remember, your h value was opposite sign. And so the h value is going to be -1. And the k value of our vertex was the same sign. And so this is going to be -3/2. And is the vertex a max or a min? So looking if it's a max or a min point, again, we want to look at that coefficient a, or that coefficient in front. And so in our case, a is equal to 1/2. And we're looking, is that a positive number or a negative number? It's positive, it's bigger than 0. So parabola has to face upwards. And so looking at that, I know my vertex is a minimum. Okay, so I know it faces up. And then looking at the vertex, I can tell if it's falling above or below the x-axis. And so my y value is negative, so it's falling below the x-axis. And so if I look at that, that tells me that this is going to have to cross my x-axis. So if I went over to left -1 and down -3/2, -1.5. We knew that the parabola again was facing upwards, so it has to cross the x-axis. And so now if I wanted to find your x-intercept. Okay, so you always find the x-intercept the same way. You always let y = 0 and solve for x. And so it's actually kind of nice when it's in vertex form to solve for that. So this is 0 is equal to 1/2 all times the quantity, x plus 1, quantity squared, minus 3/2. So I could do a lot of work and I could distribute out that x plus 1 times x plus 1 and then try to factor that, but that's a lot of work where it's already in the form where I can use the square root method. I have a perfect square and I don't have any variables of x outside of that. And so let's get our constant to the other side. So let's add 3/2 to both sides. And so when we add 3/2 to both sides, we get 3/2 is equal to 1/2 times the quantity x plus 1, quantity squared. Okay, so I don't like that 1/2 in front of my quantity squared. Well, we can clear fractions, that I could have done this before if I had wanted to. We can clear fractions because it's an equation. And we can do that by multiplying both sides by the common denominator, which is 2. So I'm only doing it to this 1/2 because it's not addition in between the 1/2 and that parentheses, or I would have to distribute that too. So the whole point of that was so those fractions went away, and now I have 3 is equal to the quantity of x plus 1, quantity squared. So now we can use our square root method. Take the square root of both sides of our equation. Don't forget to put the plus or minus in front of the square root of the number. And so I have this plus or minus the square root of 3 is equal to the square root of x plus 1, quantity squared. So our square root goes away. I'm sorry, the square root cancels our square. So this is x plus 1 is equal to plus or minus the square root of 3. So if we subtract 1 on both sides, we get -1 plus or minus root 3 is equal to x. Okay, because we're going into graphing this, having it in exact form is not really helpful. And so plugging that into a calculator to figure out approximately where those values are on the x-axis, I get -1 plus square root of 3 is about 0.7. And if I did -1 minus the square root of 3, I get about -2.7. Okay, so I'm just going to go back up to that picture, and we can actually label that now. We know, I guess we can do that later. So we had a value at -1, our vertex. X was -1, Y was -3/2. We just found our X-intercepts, which was at 0.7. So here's my 1, here's 0.7 about, just approximate it, and -2.7. So looking at this, I know that my Y-intercept, because of how the problem's going and where my X-intercepts are going, that my Y-intercept must be below this X-axis. If I got a positive number, I know something's wrong with my shape because it's not going to make a parabola. And so sometimes, a lot of times, when you figure out where the vertex is, your X-intercepts and Y-intercepts, you can figure out that you maybe did something wrong when it doesn't make a parabola, and you can go back and look for that error. Okay, so one other thing that I wanted to do to graph this is find that Y-intercept. And so to find the Y-intercept, we're letting X equal 0. And we're going to solve for Y. So if this wasn't in vertex form, looking at it in standard form would have been the easiest, but it's in vertex form. And so we're looking at when is Y equal to, it was 1/2 all times the quantity X, the X is 0 here, plus 1, quantity squared, minus 3/2. Okay, so I just want to simplify that to get my Y value. I notice 0 plus 1 is just 1. 1 squared is just 1. So we're just left with 1/2 minus 3/2, which is equal to -2/2 or -1. So we have a Y-intercept at 0, -1. So if we go back up and plot that, we have it here. Okay, so making our graph. I'm actually impressed how well that came out. It looks like this. And then looking at this, we can tell what the axis of symmetry is. It's always the X value of the vertex. So remember that's that dotted line that's really not there. But if you folded the paper on this dotted line, the graph would lie on top of each other. And so the axis of symmetry, so if I asked you what is that equation, and so I wanted an equation, not just the X value, because that's not an equation. So the axis of symmetry in our case is I didn't spell it right. So if you look at it, it's a vertical line going through -1, X equals -1, so it's X equals -1. What if I went further and I asked, what is the domain and range? Okay, so remember domain, looking at your graph, there's a couple ways to do it. You can look at your graph and it's all the X values your graph hits or going to hit, or you can look at your equation. Are there any values of X that would give you a non-real number back? Well, there's no values of X that we have to exclude because that was a quadratic equation. And so the domain is going to be all real numbers. One way to write that, if it's interval notation, is negative infinity to infinity. The range, though, and the range is always really easy to look at once you have the parabola or know what the vertex is and what direction it faces. So the range is all the Y values that your graph is going to hit. And so it's either your Y value is going to be the maximum value of the Y values your graph hits, or it's going to be the minimum value, the smallest value your Y values hit. And so looking at this and the direction my parabola is facing, I can tell that the smallest Y value my graph is ever going to hit on here is when Y is negative 3/2. And then I hit all the Y values because this is going to go up forever to infinity. And so my range, I'm going to have the Y value always go from smallest to largest when you're looking at interval notation. So I have negative 3/2. I'm including it because our graph does hit that, and that is a Y value on our graph, to infinity, parentheses. Okay, so that was just a quick review of what we had covered last Thursday at the end of class. We had also covered last Thursday nonlinear inequalities, so less than or equal to, greater than or equal to, or strictly less than or greater than. So if you missed that lecture or haven't watched it, you're going to want to go back and watch how to do that, because solving nonlinear inequalities is a lot different than solving just linear inequalities. So now we're going to jump into 11.5 in this book, which is, again, graphing quadratic equations, but being able to put it into vertex form in order to help us graph if we're given to it not in vertex form. Or is this 11.6? I'm sorry, I think we're 11.6. I'm going to teach the right thing. I might just not say the right section. So 11.6. which is further quadratic equations. Okay, so if our equation is not in that vertex form, there's a couple ways that we can approach finding the vertex. One of them is to put it in that vertex form. And so let's first talk about that. And then I'll give you a formula to be able to find the vertex by just looking at it in standard form. So standard form is the y is equal to ax squared plus bx plus c. So that's a standard form of a quadratic equation. They have to have that stipulation that a can't be 0 or it's not quadratic. So in order to put it into vertex form, so let me just write that. That's standard form. And then vertex form. So that was the A all times the quantity X minus H, in parentheses, that quantity squared plus K. So notice the vertex form has a perfect square in there. And there's no variables outside. That K is representing some number. And so in order to jump from standard form to vertex form, one way to do that is to complete the square. So we can complete the square. On the standard form. Of a quadratic equation. To put it in vertex form. Okay. So hopefully you're not thinking, oh no, completing the square. I didn't like completing the square. We're going to do this a lot in math, so got to get a grip on it. Come see me in student hours if you need help. But remember when we were completing the square, a couple cases had to happen. That number in front of the x squared had to be 1. So if it wasn't 1, we got rid of it or made it 1 by dividing every single term by that number. Unfortunately, if I do that, then notice that I would have a y divided by a number a here. I don't want that. I want this y equals. I mean, I can divide by a, and you might see some videos that do that. But in this case, I'm going to instead, I want to factor a out of my terms that have the x in it. So in our case, we're going to do it a little bit differently here. And the first step that you want to do is you want to factor the coefficient in front of x squared, which is our a value, out of the x terms, or the terms that just have an x. Okay, that just has an x. So that constant that doesn't have an x on it, you're going to leave it alone. So once you've done that, you're going to complete the square inside the parentheses. So now we've done that, we're going to complete the square. Inside the parentheses. I was just kind of thinking about something when I wrote that down. So a common error students do is when they were pulling out that coefficient of a in front of the x squared terms, they also like to pull out the x because they have those in common. Do not pull out the x while you pull out a. So don't factor out x with it. So I'm going to complete the square inside the parentheses. The number you added inside the parentheses needs, basically we're trying to add 0 here because we're trying not to change the equation. We want equivalent things. And so we added something to one side of the equation. And so we can take care of that by either adding it to the other side of the equation, which I don't want to do because I want the y by itself. Or if I add something to one side of the equation and also subtract that same number on that side of the equation, then it's like adding 0. And so I'm kind of manipulating this by adding 0. And so I just added some number inside the parentheses. This needs to be canceled. Not really canceled, because if I cancel, I'm undoing what I'm doing, but canceled by subtracting. Be careful here. It's not just that number that I added here, but it's a times the number added. From outside the parentheses. Okay, so once you've done that, and a lot of times I don't write this step out, I kind of just explain it. So once I explain it, maybe it will be a little more clear. But once we've completed the square inside the parentheses, we can now rewrite that as a perfect square. And we subtracted the same number that we had added technically on that side because of the coefficient a of outside that parentheses had to be distributed. And so now put it in vertex form. Okay, so let's do an example and walk through the steps. I'm going to start off easier, or we're going to start off easier, where that coefficient in front of the x squared is 1. So we don't have to worry about factoring that number out of those terms. So let's say we had y, or f of x, is equal to x squared plus 5x plus 4. And we want to, part A, put this in vertex form. Okay, so first step, make sure that the coefficient in front of the x squared is 1, which it is. If it wasn't, we would pull it out of the x squared and the 5x. Now that it's 1, basically what I'm trying to do is complete the square on just those x terms. So I'm just going to rewrite this. So I have y equals x squared plus 5x. So notice, or remember, that there was some number that we added in here to make this a perfect square. I'm going to add something here. But like I was just saying before, if I add something in here, it's like I have to subtract it too. So I'm adding and subtracting the same number, which is similar to adding 0. And then I have my plus 4, that constant still needs to be written here. So I need to figure out what number would make that a perfect square. So remember, it was the number that you added by itself to get this b term. So what do I add to itself to get 5? So one way to do that, we found that by dividing this number by 2. This just happens to be a fraction and doesn't reduce. So 5 halves plus 5 halves, right? That would give me 10 halves, which is 5. So this number here had to be that number that you had added by itself. You had to square it. So 5/2 times 5/2 is 25/4. So this was the number that we had to add to make those first three terms a perfect square. But again, it's like I'm adding 0 to this one side of the equation. So it's like subtracting off 25/4. So this right here is a perfect square. So this would be y is equal to, so that same quantity that you'd multiply to get x squared plus 5x plus 25/4 is x plus 5/2. And then we also need to simplify by adding our negative 25/4 plus our 4. Well, in order to sum these, I need a common denominator. So this is really negative 25/4. My common denominator is a 4. So negative 25/4, I can rewrite this as 16/4. So negative 25 plus 16.
I do have a question. What was the point of doing the 5/2 plus 5/2 equals 10/2 equals 5 when all we needed was the 5/2 to the second power to get our...
Yeah, so no, there was no point in this. This was just showing that this is the same number that you would add would give us back the same. This middle term.
Okay.
So you're right. Normally I don't show that. It's just harder to see that same number you're going to add to get that when they're fractions like this.
But because with any number, whether that was a 5, 6, 7, it would still be over 2 to the second power or squared. Okay.
Yep.
Okay.
You always do it that way. You're right.
Thank
you. I didn't write it out, but basically this right here is negative 25/4 plus 4. I was getting a common denominator, so multiplying 4 by 4/4 is 16/4. And so adding those together, it's actually minus 9/4. So that was just combining to get this. So we just did it. We put that in vertex form. And so now we can tell what the vertex of that parabola is. And we can go about solving or graphing. Okay. Are you guys okay with graphing for now? And then we can look back, or we can graph. We can continue to graph.
One more question. How did we get the 16/4?
I had to add this negative 25/4, what was outside of these parentheses, together. But notice one is a fraction and one is not. That 4, and maybe it will help if I rewrite it up further.
Oh,
this is like 4/1.
You had to times it by the 4 and got the 16. Okay, sorry.
Yeah.
Thank you.
Yep. Any other questions? So you guys should be able to graph this, and maybe we should just quickly do that. So looking at that, I can tell what the vertex is. And the vertex again is opposite sign inside the parentheses. And so it would be -5/2. Same sign outside of the parentheses, so -9/4. So that might be easier if you look at this as fractions. So that's -2.5 and -2 1/4. I can tell what my A value is. That's a 1 because it's no number is shown outside of that parentheses. So this is greater than 0, and so I know my parabola faces upwards. I notice that my vertex is below the x-axis. It's facing upward, so it's going to cross the x-axis, and so I know that I'm going to have a intercept, x-intercepts. Now I can use the form that we just found. Sometimes though, if you already have the original form, it's easier to use this. If I can just factor this really fast, I can tell what values would set this equal to 0. And I notice there's two numbers that multiply to 4 and add to 5. So I could factor it that way, and I would get back -1 and -4. Or I can use my square root method. I'm just going to do that really quick because it works and just because of practice. So if I let y equals 0, I have 0 is equal to x minus 5/2 quantity squared minus 9/4. I would isolate my square. I would add 9/4 to both sides. So I have 9/4 is equal to x minus 5/2 quantity squared. I would take the square root of both sides. So square root of a fraction is equal to the square root of the numerator over the denominator. So I get plus or minus square root of 9 is 3 all over square root of 4, which is 2, equals square root and the square cancels, leaving us with just x minus 5/2. If I add 5/2 to both sides, I get x is equal to 5/2 plus 3/2 and 5/2 minus 3/2. They're already common denominators, so it should be easy. 5 plus 3 is 8. 8 over 2 is 4. So it's going to pass at x equals 4, or 5 minus 3 is 2. 2 divided by 2 is 1. Did I miss something? Okay, I knew something was wrong, and I would have noticed that when I had plotted the points. I also knew something was wrong because I factored it for you, and I had told you that I was going to get -1 and -4. So
Wasn't it a plus
Yeah.
x plus 5/2? Okay.
So this is where I was saying, you know, you can kind of by what you're getting, you can tell if you made an error or not. And maybe I just purposely put that -1/2 in there just so we could see that. But this should have been a plus. This should have been a plus. This should have been a plus. That means actually instead of adding 5/2, I would have had to subtract 5/2. So -5/2 plus 3, that's -2/2, which gives us the -1. Where -5 minus 3 is -8, and -8/2 is -4. So we can pretty much graph this.
How are we still getting the negative?
Adding two negatives is negative. And our -5 plus 3, -5 plus 3 is -2.
But wouldn't it?
It should be negative because this is a -2.5 and -2.1. What was it? Let's say -2.25. That was where our vertex was we found. Notice if my x-intercepts, which I had saw before, was 1 and 4, this would not work. My vertex shouldn't, it has to be in between. Where if it was -1, sorry, my scale is not going to be great, and -4, this is falling in between here.
So I guess my question is, because we do, it is the vertex does, on my paper, I took the notes, it says the -5/2, but if we got plus or minus 3/2 equal.
Yes.
So I guess my question is, if we're adding 5/2 to 3/2 and we're minusing, we're doing 5/2 minus 3/2, how are we getting the -5 up?
Okay, so negative, so you're right. Instead, though, we had to subtract 5/2 because of me writing the problem down wrong. And so when we subtract 5/2 on both sides, we get -5/2 plus a 3/2. So add your numerator. So -5 plus 3 is
Oh, gotcha.
-2.
Gotcha. Okay. Sorry. Thank you.
Nope.
Caught up.
And that's where it's helpful if I write things down more too. So one more value I have to find that would be helpful would be that Y-intercept. This again is where looking at your original problem and the form it's in, it might be easier instead of the vertex form. So like in this case, if I plug in 0 for x to find my Y-intercept, it's just going to be my constant up here. So if I plug in 0 for x, I get 0 squared plus 5 times 0, 0 plus 4. So I get my constant y is 4. So it's crossing the y-axis when y is 4. And this is not to scale. Okay, so there's completing the square to put it in that vertex form. We'll look at in a minute doing it when a is not 1. And let me give you guys a break real quick. Okay, so we're looking at, again, putting quadratic equations in standard form into vertex form. And so if we had the following, f of x is equal to -2 times the quantity x squared, and then plus 4x plus 6. So we want to complete the square on the x terms to make that a perfect square. Unfortunately, the number in front of the x squared is not 1. And in order to complete that square, that number has to be 1. And so we can make that a 1 by factoring out the -2. And we just want to do that for the x terms. So we want to make a equal 1. Actually, it's kind of weird because a is a little differently in this case too. So you might make the number in front of x squared 1. And again, we were just going to factor this out of the x terms only. So factor a out of the x terms only. Okay, so we're pulling that -2 out of just the x terms. So we get f of x is equal to -2 times the quantity x squared. And if I pull a -2 out of positive 4x, I'm left with a -2x. I am going to leave some room inside my parentheses because I'm going to add some number in here. So maybe let's say plus some number here, because that's what we want to add to make it a perfect square. But if we add something to this one side of the equation, remember I said we have to subtract that same quantity on that side like we're adding 0. And then I have plus my constant that I did not pull the -2 out of, which is 6 in our case. Okay, so now I'm trying to think to myself, what am I multiplying here? Or what am I getting right here? So that if I add the same number to get -2, multiply it, I would get, so -2 divided by 2, so that's -1, and then squaring that number, so -1 times -1, that would give me a 1 in here. So this is where we need to be careful. It's not that I added 1 technically on this side of the equation because of the -2 outside of that parentheses. That -2 technically has to be distributed to every single number inside this parentheses. And so this is really like we added -2 to this side of the equation. And so if I add a -2 to undo that, I would have to add 2. So right here, this is really plus 2. Okay, so this gives me -2 all times this quantity. Well, this quantity inside the parentheses is a perfect square. And so the same number that you would multiply to get +1 and add to get -2, we said was -1. So this is x minus 1, quantity squared. And now I have really +2 plus 6 outside of this parentheses. And so that would give me a +8 outside here. And so now I can tell what my vertex is. Opposite sign inside, so this would be +1, same sign outside, so this would be 8. So it's occurring at 1, 8. And I know that this is a maximum value because my coefficient of A is negative, which is less than 0, so my parabola faces downwards. I can also tell really quickly that this would be crossing the x-axis when I graphed it because the 0.18 is above the x-axis, and then my graph is shooting downwards on both sides of that vertex, and so it would have to cross the x-axis.
Okay, so I do have a question for you. I was trying to figure it out in my head, but I couldn't. Why are we using that 2 when in the previous example it was the same, the 25/4?
Right. It's because of that -2 that we had to factor out at the beginning to make that a 1 in front of the coefficient. Before we didn't have to factor out any number in front, and this time we did. So let me just take this quantity right here. Let me see if I can lasso it. So do you understand, like in the last part that we had to, we subtracted off the same number we added on the one side. Well, let's look at what we really added to this one side. When we put that 1 inside that parentheses, we really didn't add 1 to this side because of that -2 outside of the parentheses. If I distributed that and rewrote this without parentheses, this is really -2x squared plus 4x, which we originally had in our original equation. We just pulled that -2 out. But if I distribute this -2 to the 1 that we added in here, we technically added -2 to this side of the equation.
Okay.
So because I added that -2 there, that is where I had to undo and kind of add 0. And so I added 2 on this.
Gotcha.
And then we had over here really this +6.
Okay. Thank you very much.
Yeah.
It's very helpful.
Yeah, and that's a tricky part right there. And that's where students get caught up. But what are you really adding or subtracting here to cancel out that when you factored it? So I'm glad you asked that again, so we can clarify it. So let's look at another one where maybe A is not 0. I mean, not 1. Okay, so they're throwing hard ones at us because they have numbers that aren't actually factorable or doesn't factor out of that BX term. So maybe we should still look at that so that if you come up with one of those on my math lab, you can do it. Okay, just want to make sure I have enough room later. So if we had f of x is equal to 4x squared minus 2x plus 1. And we want to put this in vertex form. So again, in order to complete the square, the number in front of the x squared term has to be 1. And so you're always going to take your a value, which in this case is 4, and you're going to pull it out of just the x terms itself. And so if I pull a 4 out of 4x squared, I'm just left with x squared minus, so I have to think to myself, what if I pull out a 4 from -2x? Really, what am I left with? Well, think about this. If you looked at -2 and we pulled a 4 out of here, we want it to be left -2. So if we just put that same number in the denominator, 4 times -2 gives me -2. So this is the number I really technically have to have in there. And maybe I should just leave it as -2 instead of 1/2. It's up to you. Okay, so this was where then I needed to figure out what number was I adding to make this a perfect square. And then I had to figure out what was going to cancel that out here to really sum to 0. Plus that constant I did not pull the 4 out, which is 1. Okay, so we have f of x is equal to 4 all times the quantity. So what are we going to add in here? So divide that by 2 and square it. So -1/2, oops, or -2/4, I'll just leave it that way, divided by 2. So that's the same thing as multiplying by 1/2 and square it. So notice when I do that, those 2's cancel and I'm left with -1/4 squared. So -1/4 times -1/4. Well, -1 times -1 is 1. All over 4 times 4 is 16. So I am technically want to add 1/16 in here to make this a perfect square. But technically I need to think about what am I really adding on this side, I need to subtract it. So I'm going to have minus, well, 4 times 1/16. That's really what I added on the side when I distribute the 4. So I'm going to really subtract off 4/16 here. So this one, what's inside the parentheses, what we just added, made that a perfect square. And so to rewrite this, this is the same thing as x minus 1/4 quantity squared. And then we have minus 4/16. Well, in order to add 1, I'm going to rewrite my 1 as 16/16. So I get f of x is equal to 4 times the quantity x minus 1/4 quantity squared. And so negative 4/16 plus 16/16 is positive 12. So plus 12/16. I can reduce that a little bit. So I have 4 times x minus 1/4 quantity squared plus, they both have 4 in common, so I'm left with 3/4. Okay, so here is a case I can tell that this would not cross my x-axis. I can see that my vertex is opposite sign, so it's 1/4, same sign 3/4. So 1/4, 3/4 is where my vertex is. My a value is 4, so it is a parabola facing upwards. If I look at where 1/4, 3/4 is on my x and y axis, so going over about 1/4, and I'm just gonna do this as 1/4, and I'm going up 3/4. I have a point here. Again, I know that a is greater than 0, so it's going upwards, and so if this goes upwards, it cannot cross the x-axis. So that would save me a lot of work if I had asked you to find the x-intercept if it exists. You either need to explain to me that it doesn't exist here by showing exactly what I just showed, where my vertex was, what direction it was facing, and that it couldn't cross because of that. If I asked you to show me algebraically that that did not cross the x-axis, we would have to set our y value equal to 0 and solve. And so there's a couple of things I could do there. Let's look at that real quick because this is kind of a good review for the final and what we're doing here in graphing. So I want to look at both equations, the vertex form equation that we just got, and I want to look at the standard form equation that we originally started with. So let me grab both of those. Yep. Okay, Solve for the x-intercept. Okay, so there was two ways that we can do this. If I distribute out x minus 1/4 times x minus 1/4, distribute my 4, I would get back this original equation that we had started with. But that would be a lot of work if I had started with this equation on the left-hand side to find the x-intercept. And so in this case, we're going to solve by the square root method. And so I'm going to set my y value equal to 0 is equal to 4 all times the quantity x minus 1/4 quantity squared plus 3/4. Here, if I want to use the square root method, I need to isolate the square. I would subtract 3/4 on both sides of the equation, and I would get negative 3/4 is equal to 4 times the quantity x minus 1/4 quantity squared. In order to take the square root, I want to get rid of that 4 in front. And so I can multiply both sides by 1/4 or divide both sides by 4. Oops. So multiply by 1/4. So this gives me 1/4 times negative 3/4. This is negative 3/16 is equal to x minus 1/4 quantity squared. Notice when we take the square root of both sides of the equation, we're taking a square root of a negative number, and that is not a real number. So some of you, when you were solving using the square root method on the test, or you were using quadratic formula and you got a negative underneath the radical, you told me that there was no solution. And that is a solution, it just is not a real solution. So this is not a real number. So this tells me it does not cross the x-axis. So the other way that we would have found this was we would have had to set this equal to 0, and we could have, it doesn't factor because there's nothing that I can multiply to give me 4 and add to give me negative 2. And so the other way I would have had to done that is use the quadratic formula to solve there. But I actually don't want to do that just because of time's sake. I thought I was going to do it to show you different ways, but that's okay. Okay, so after I just showed you how to find or put a quadratic equation that was in standard form into vertex form. To find the vertex, there's another way to do it. So vertex formula. So if you were given a quadratic equation in standard form, y is equal to ax squared plus bx plus c. Instead of putting it in vertex form, we can find the vertex by the following. The x value of your vertex is going to be negative b all over 2a. The y value of your vertex, so instead of calling this y, maybe this had been instead an equation called f of x, which is the same thing as your y value. Remember, in order to get your y value of a point, you plug in that x value of your point wherever you've seen x. So to find the y value of your vertex, we will look at f of negative b over 2a. And that would give us our point. Okay, so let's just show that we got the same vertex from the example that we had to find that, put it in vertex form, which was a little difficult because of the fraction. We had y was equal to, or let's call it f of x. Y is the same thing as f of x, which is equal to -2 times x squared. What was it? I'm sorry. That was not our equation. It was 4x squared, right? I should have written it down. Minus 2x plus 1, or plus 2x minus 2x. Okay, so if I look at this, I can tell what my value A is, what my value B is. I don't need to know what C is in this case to find the vertex. And so our X value, which is our H value here, this is negative B over 2A. And plugging our values in, I have B is, let me just write it here, sorry. So A is 4, B is -2. So this is equal to negative B, which is -2 all over 2 times A, which is 4. So negative of -2, that's +2, all over 2 times 4, which is 8. That reduces to 1/4. So that's the H value of our vertex, and now we need to figure out what the Y value of the vertex is. And so we can do that by plugging in, just happened. Oops. Darn it. Things moved around, got me sidetracked. Sorry about this, technical difficulties.
Is that a smudge mark or like a little man dancing?
It's my smudge mark. My computer just froze. Darn it. It's trying to save. Let me just do that real quick. Maybe that will stop it from freezing. Where did my Math 52 class go? Oh, there it is. Okay, it still looks like it's frozen. Okay, let's see. All I need to do is plug this number back in wherever I see an X and f of X. Let's insert a blank page. I'm wondering, Okay. Darn it, guys. I need to plug in 1/4 wherever I see an X up here. And so if I do that, if I plug in, now it's going to do my eraser. I guess this is a good time to stop class, if this will not do work. But basically, if you plug in 1/4 there, you get 1/4, that's quantity squared. That's going to give you 1/16. 1/16 times 4, that's going to give us 1/4. So 1/4 times or plus -2 times 1/4, which is -1/2, plus 1. That should give us back what we originally had up here. So notice our X value of our vertex was 1/4. When you plug that back in for X, you should get back 3/4 for Y. Let me pull that back down.
Do you have wind chimes?
No, that's our clock.
Oh,
like
it's
grandmother clock that chimes on the quarter of the hours, and
very relaxing.
I don't even hear them anymore. Okay, so I'm gonna pause the video. That's as far as I can take that because of the technical difficulties.